What is the best way that I can select to store and organize so that I can use the data efficiently? If I enter the value inside this stack, that operation I will call it as a push operation. Traversal in the sense you are visiting all the data what you have stored in the data structure. Hello everyone. I welcome all of you to the first session on Data Structure 1 Linear List. So what exactly we'll be discussing in this chapter? So guys, I have huge amount of data. So how exactly in different way I organize the data? That's what we are going to discuss. Let's start without wasting much of your time. So introduction. So please understand, a data structure is a particular way of storing, and organizing the data in a computer so that it can be used efficiently. What is that? I have the data. What is the best way that I can select to store and organize so that I can use the data efficiently? That is what we call it as a data structure. Fine. So let me take an example for all of you. Imagine I have 100 t-shirts and 100 pants. I have just dumped it, okay, in my room. Like, how all the boys, we do that, right? The same way, I have just dumped it. I have just piled up all my shirts and pants. So imagine the space that the shirts and pants have occupied, right? So in the same way, I have pressed all my clothes and I have folded and I have placed it in one particular place. So in the scenario number one, in the example number one, imagine the space it has occupied where I have dumped all the clothes. In the scenario number two, where I have pressed and I have folded and I have kept it. So what is the amount of space it has occupied in the scenario number two? Obviously, in the scenario number two, it has occupied less space. In the same way, I have the data. I should select what is the best way that I have to organize my data to save the memory, and also I can use the data efficiently. So this is what I will call it as a data structure. So guys, let's move on to the next concept. I have different types of data structure. What is that? I have different types of data structure. The first one that I have is simple data structure. What is the first one? Simple data structure. What is the second one that I have? I have compound data structure. Please understand, I have two types of data structure. So what is the first one that I have? Data structure has got two types. The first one is simple data structure and the second one is compound data structure. So this is what you need to understand. What exactly the simple data structure is all about? Please listen to me carefully. These data structures are normally built from the primitive data types. Primitive in the sense what? Fundamental data types. If I am constructing a data structure with the help of primitive data types. Primitive in the sense basic fundamental data types. What exactly the fundamental data types is all about? So, yes, I have integer, floats, characters. All these things I will be calling it as a primitive data type. If I am forming a data structure with the help of primitive data types, then I will be calling it as a simple data structure. That is the first one that I have. What exactly then the compound data structure is all about? Yes, simple data structure can be combined in various ways to form more complex structure. I am using the simple data structure to form the complex structure. That is what I will be calling it as a compound data structure. What is that? Using this in the sense what? So my hand should show the simple data structure. Using simple data structure, so if I am able to form a complex structure, then I will be able to form the complex data structure. This is what you need to understand. So can you tell me, sir, so which will comes under the complex data structure? So we have linked list, we have stack, queues and trees. These are all the example for compound data structure, right? These are all the example for compound data structure. I am using the simple data structure to form the complex structure. So with the help of this complex structure, I will be able to form the compound data structure. So I have listed some of the data structure under the compound data structure. So this is what you have to understand when it comes to the different types of data structure. So let's understand that one by one. So I have these many data structures. So the first one is linear list array, second one is stack, queues, linked list and trees. Guys, what exactly linear list array is all about? What exactly the linear list array is all about? We have already discussed about arrays in the previous class. I will just give you the brief knowledge about all this different data structure what we have. So we don't have all these things in detail. You just have to know how exactly it is working. That's it, right? So let's start with a linear list array, right? So in the name itself, you will be able to make out linear in the sense what? One by one. So one by one. So that is what we call it as a linear. So sequentially, so one by one, if you are able to store the data, that is what we call it as a linear. That is what we call it as a linear. Please understand, in this data type, we are using a data type called array. We are using a data type called array. What exactly will happen in the array? So I will be storing the data one by one. I'll be storing the data one by one. For example, I'll be storing something like this: 10, 20, 30, 40, 50. So I'm not supposed to give space here. So whatever I have stored here, I'm not supposed to leave space, and then I'll not be able to store the value here. So that is what we call it as a continuous allocation of memory for the data. Continuous allocation of memory for the data. That is what you need to understand. The index always starts from 0. The index always starts from 0, 1, 2, 3, 4. This is what you need to remember when it comes to the point of index. So guys, so remember all the data whatever I'm storing here, so that should be of homogeneous. What is the meaning of homogeneous? If I'm storing the data in the array, so I should be storing only one type of data in the array. That is what you have to remember. If I'm storing the data inside the array, I have to store the data of one single type. If I'm storing the data of integer, I have to store only integer. I cannot store the multiple data inside the array. That is what you have to understand. So this is all about the linear list array. So guys, what is that you will understand? So you are storing the data continuously with the help of array. So this is how you will store the data inside the array. So what is that? So 10, 20, 30, 40, 50. So we'll have the index 0, 1, 2, 3, 4. So you will not be able to give any gap in the middle is what you need to understand. What exactly the stack is all about? Stack, in the sense, you should remember one thing: CD stand. You should remember the cooker punch. Okay, you should remember the bangles. What exactly you are talking about, Cha? Yes, I'll come to that example a little later, right? So guys, stack will exactly look like this. Stack will exactly look like this, right? What is the principle the stack follows? First in, last out. First in, last out. I will insert the bangle to my hand. Okay, the first bangle whatever I have inserted, so that will be removed at the last. Yes or no? The same fashion the stack is working. Imagine I will be entering the first element or the data item to the stack. So right now in my stack I have A. So this was the first element before I enter this, right? After that I'll enter B. Then after that I will enter C. After that I will enter D. So this is what I will call it as a stack. This is what I will call it as a stack. So if I enter the value inside the stack, that operation I will call it as a push operation. That is what I will call it as a push operation. The process of inserting a data item inside the stack is what I will call it as a push operation. Suppose if I want to remove this, okay, if I want to remove this, I cannot remove A or I cannot remove B or C. First I have to remove D. So this operation is what I will call it as pop. This operation is what I will call it as pop. And I have one pointer. So guys, So that pointer I will call it as top. That pointer I will call it as top. Always this pointer points to the top element of the stack. Always this pointer points to the top element of the stack is what you have to understand. Fine. So I have the stack. So I'll be able to insert the values one by one. So, and it follows first in last out method. It follows first in last out principle, in fact. So fine, we understood push, we understood pop, and we understood the top pointer. It points to the top of the stack always. So this is all about the stack that you need to understand, right? So moving on to the next data type that I have. What is the next one that I have? I have queue. What is the next one that I have? I have queue. What exactly queue is all about? What exactly the queue is all about? Imagine we are going to a movie. First we need to book a ticket, like, just imagine Book My Show is not there for all of us now. We have to stand in a queue, right? So I will stand in a queue. The first in will be first out. So if I'm standing first, so I'll be coming out of the queue first. That is what you have to understand. So guys, so this is what I will call it as a queue. So this will have two ends. One is rear end. One is rear end, another one is front end. One is rear end, another one is front end. Imagine the ticket counter is here, okay? So always the insertion of the data element will happen at the rear end. Insertion will happen at the rear end. So whatever you have inserted, so if the data comes here, and the deletion will happen at the front end. Deletion will happen at the front end. You will go from this side and you will come out from this side. That is what we call it as a stack. That is what we call it as a stack. So first in, first out. First in, first out. That is the principle the queue is following for all of us, right? So we have different types of queues, guys, which we will be discussing in detail in the coming session, right? So this is all about the basic knowledge that you should have with respect to the queues. So what is that you will remember? So queue is one of the data structure where the insertion of the data will happen at the rear end and deletion of the data will happen at the front end, right? So enqueuing in the sense you are inserting the data into the queue. Dequeuing in the sense you are removing the data from the queue is what you have to remember with respect to the queue, right? So the next data type that I have, is it data type? The data structure. So the next data structure that I have is linked list. The next data structure that I have is linked list. So linked list in the sense, first thing that you should remember is node. This is what you have to remember. So this is what I will call it as node. Whenever I speak about this linked list, imagine we have a train. So how exactly the train is there? The same way I have something called node, okay? What is that I have in this node? So we have two parts in this node. One is for data. One is for data. Another one is for link. Another one is for link. Whatever the data that I want, I can store here. There is no restriction. There is no restriction. So whatever the data that you want, you can store it in this place. So this is the link part. This contains the address of the next node. Suppose if I have the node here, so what is the address of this node? So this address will be stored in this link part. So this points to this node. Again, I have the data here and I have the link part to the next node, right? So in the last node, so guys, in the link part, I will have null. I will have the null. So that is the end of the linked list. That is the end of the linked list. So that is what you have to understand. That's what you have to understand. So what is that you will remember? In the linked list, you have node. So guys, data part and the link part. Link part contains the address of the next node. That is what you have to remember in the linked list. Moving on to the next data type that we have. So we have tree. So you are trying to represent the data in the form of tree, that is root node. Root node will have the leaf nodes. Root node will have the leaf node. So this is the structure of tree. You will be representing your data in the form of tree. You will have the root node and you will have different levels. You will have the different levels. The last level, whatever you have, this is what we call it as a leaf nodes. This is what we call it as a leaf nodes. So guys, using this way, we will be representing our data. So we have different types of trees. We have different types of trees, and in this tree, we have different levels. This is how we represent our data in the form of trees. This is a brief introduction to all of you with respect to the different data structure that we have. Moving forward, we have operations on the data structure. What are the different operations that I can perform with respect to all this data structure? What is the first one that I have? The first one that I have is insertion. The name itself says to all of you, insertion, in the sense you are inserting the data, right? So that is what you have to remember. To add a new data item in the given collection of data items, just have to remember insertion in the sense you are inserting the data. Deletion in the sense you are deleting the data. Traversal in the sense you are visiting all the data what you have stored in the data structure. Say for example, I have the queue, right? So I have the queue. Okay, so this is the rear end and this is the front end. So traversal in the sense you are visiting all the data. That is what we call it as a traversal. That is what we call it as a traversal. What is the next one that we have? Searching. Searching in the sense you have an element in your hand, so you want to find whether that element is there in that particular given data structure or not. So I have 10, right? Let's take 10. So I should check, do I have 10 in this queue or not? So I have 10, 20, 30, 40. So I will start matching. So is it 10? No. Is it 10? No. Is it 10? No. Is it 10? Yes. I have an element in the queue. So this is what we call it as a searching. I want to simulate and explain rather than reading the definitions for all of you, right? That's the reason I'm not reading all the definitions for all of you, right? So what is the meaning of sorting? Sorting in the sense arranging the elements either in ascending or descending. So that is what we call it as a sorting. I can also perform sorting in the data structure. So, and also I have merging. Merging in the sense combining. Merging in the sense combining. I have two linked lists. I have two queues. I will be able to join two queues. That is what I will call it as merging. That is what I will call it as merging. This is the different operations that I can perform with respect to the data structure. What is the next concept that we have? Linear list. So guys, already we have discussed all these things. What is that? You have to remember, if I say linear, so you will be storing the data one by one. You will be storing the data one by one. Already I have explained all these things. Let's just have a quick recap of all the points. So one by one, sequentially you will be storing the data. That is what you have to remember. Then after that, what is that you will be remembering, guys? So you will be storing only homogeneous data. Homogeneous in the sense what? If you are using arrays, so you should be able to store only the homogeneous data. Homogeneous in the sense only one type of data. What is that? Only one type of data. That is what I will call it as homogeneous. And there is no limit that you should be able to store only this much amount of data. You can store infinite number of data, is what I would like to tell you at this point of time. How do you identify the size of linear list? How do you identify the length of the linear list? So this is the formula that you have to follow. Upper bound minus lower bound plus 1. Upper bound minus lower bound plus 1. So guys, so this, let us imagine 1, 2, 3. Okay, 0, 1, 2, 3. This is what I will call it as upper bound. This is what I will call it as lower bound, right? So what is the size? What is the size? So guys, so easily, okay, suppose if I have 3, so you can just tell 4. You don't have to calculate this easily. You can directly, you can say that 4, because I started with 0. That's what you have to understand. If you want to substitute the formula, let's take, so what is the lower bound? So you have 3. So 3, okay, what is the next formula? Minus, so I have lower bound as 0 plus 1. So what is the answer? 4. So you don't have to calculate that. Directly you can arrive at the size, right? Suppose if you don't know how to calculate, so guys, how to calculate the shortcuts. So you can just use this formula. This is how you will be calculating the signs. What is the next topic that I have? Guys, I have linear list data structure. Using this concept, I'm trying to write the algorithm for linear search. I'm trying to write the algorithm for linear search. What exactly I'm doing in the step 1? Sir, I'm setting the lower bound. I'm setting the lower bound in the step 1 and I'm setting the upper bound in the step 2. So I will be initializing. Imagine I have the array. I'm naming it as AR. So this is my array. So this is my array. The array name is AR, right? So I have the array something like this. And I'm pointing the CTR pointer to the lower bound. Okay, so I'm treating U as a upper bound. I'm initializing U as a upper bound here. That is what I'm doing in the first step and second step. Then after that, please understand, I'm just comparing if AR of CTR, in the sense this is AR of CTR, this particular location, so is equal to item. Let us imagine item is equal to 10. So what is the item value now? Item is equal to 10. So do I have 10? Suppose if I have 10. Okay. So AR of CTR is equal to item. Yes, it is true. It is there. I will be printing print search successful. All the statements I will be printing. Then after that, I will execute break. I will skip the loop. I will skip all these things. I will come to the end. I will come to the end. When? If I get the element. If I get the element. Let us imagine I don't have the 10 here. I don't have the 10 here. So what will happen? So it will not execute the statement. I mean to say that, so the match is not, there is no match here. So it will skip all this statement. It will skip all the statement. Directly it will execute the statement. What happens here? CTR plus 1. CTR plus 1 will happen. The increment of this pointer will happen. Now it was here. It will come to here. The CTR will come to this point. So what happens here when it comes to this particular point? So please understand, CTR, once this statement is executed, it will compare. Is CTR greater than upper bound? Is CTR greater than upper bound? No, it is not. Then again, so this comparison will happen. So if CTR is equal to item, then again the comparison will happen here. Whatever the data that I have here, so this is equal to item or not. This is equal to item or not. Suppose if I don't have the match, so this will be skipped again. So increment will happen. Then after that, the comparison will happen here. CTR is greater than U or not. If it is not, then again this will be repeated. So guys, like this, until it reaches the last element, it will be keep on checking if the element is not matched. Suppose if it finds the element, it will break the matching there itself and it will come out of the loop. This is how the linear search is working for all of you. With this, I have come to an end of this session. So hope the session was useful for all of you. I'll be coming with a lot of different algorithms that we have. So in the same chapter in the coming sessions. Thank you very much.